Now today's video is going to be a little bit longer than normal because we're starting a new section on geometry, and our lesson today has a lot of notation and definitions and things. So I would recommend getting a notebook to write them down. That way you don't have to watch this long video again. We need to start our discussion by talking about a word called dimension. Now you've probably heard this before when you talk about 3 dimensions, 2 dimensions, different objects and different things that you've experienced. In our world, things have 3 dimensions. And so you've seen examples of things like this box has length, it has width, and it has height. And they talk about those 3 dimensions, which describes the shape of this box. Now, every object that you've experienced so far has 3 dimensions. This is important because some of the things we're going to talk about today have something other than 3 dimensions. So you could say, me, for example, I have width, I have height, and I have depth. Every person is that way. You could maybe take something like this replica of Mjolnir. Has length, it has width, and it has height. And every object that you've interacted with has those 3 characteristics. When we get to our geometry, the first definition is point, and point is defined as an object that has no dimension. So what does that mean? That means we've taken our width, we've taken our height, and we've taken our depth, and we've taken them all away. A point is simply a location. It is something that has been squished down to an infinite smallness so that it doesn't have any length, it doesn't have any width, it doesn't have any height. It's just a location. So points are often represented using dots, and as you can see, we could measure this dot has length and width, so this dot is not an actual point. If it was infinitely small, squished down, it wouldn't have any width or height and we wouldn't be able to see it. So we use things that we can see to represent things that are infinitely small in this case. Now points are named using capital letters. So I could call it A, or I could call it B or C. I could pick any letter that I want to, but it needs to be a capital letter. Moving on, we have our second thing, which is a line. A line is a one-dimensional object. So it has length, and that length on this line extends forever in both directions. But it does not have any height. We represent it with a line, which of course we can measure some of the height because we wouldn't be able to see it if it was infinitely skinny. But that is our representation for a line. Now, in order to create a line, we need 2 separate points. So I'm going to put 2 points on here. I'm going to call them A. I'm going to call them B, and I'm going to put another point on here called C because there's points everywhere along this line. Now, our naming uses 2 of these points. We don't need all of them. We could pick 2 of them. We'll say A, B, and we'll write those down. And to show that it's a line, we're going to draw a picture of a line above it. So this notation says we start with A, and we go through B. It's the line that passes through both of those, and it continues on forever in both directions. We could name it using some other things, and in your assignment you'll be asked to give things alternate names. So let's pick a different one. We could use the points CB, for example. That would be an alternate name. We could say BA and switch the order around. There's lots of different choices. Sometimes lines are used often enough that they give them a special name. They can have a name of a lowercase letter. So let's say I use the letter L for line. You could call this line L to represent that as well. Collinear is our next definition. Collinear means linear for line, and co, the prefix, means together. So collinear means together on the same line. These 3 points are called collinear because they are all on the same line. If I gave another point right here, let's say D, this is not collinear with those 3 points because these 3 are on a line that D is not on. Next, we're going to talk about a plane. Now, a plane has 2 dimensions. So we're going from 0 dimensions to 1 dimension to 2 dimensions. A plane is represented by a picture that looks kind of like a wall or a ceiling or a floor or a paper or something like that. It has length and it has width, and those 2 measurements continue forever in all directions. So picture this wall as a plane. It has length and it has height, and those measurements continue forever in all directions. So it goes down forever, it goes to the sides forever, it goes up forever, and this would be an example of a plane. Now, a plane does not have any depth. That would be like taking me and my depth and squishing me down so that I am perfectly flat. I have width, I have height, but I have no measurement from front to back. That would be like squishing me down into 2 dimensions. So here's our plane. Now, representation, we have this. Naming, in order to name a plane, we need 3 points on that plane. So I'm going to put 3 points right here, right here, right here. We'll call them A, we'll call them B and C, and we would just write down plane A, B, C. If you want an alternate name, you can switch the order of the letters around. We could call this plane B, C, A. Or if we had another point on there, we could choose, let's say D was on there, we could call it B, C, D. Sometimes planes have a special name as well because we use them a lot. A special name for a plane would be a capital letter. So you could call this, let's say, M. This would be plane M, where M is not near any of the other points. All right, coplanar. Let's break this one down like we did with collinear. So co, again, means together. Planar, talking about a plane. So together on the same plane. A, B, C, and D are all points together on the same plane. If I put a point out here, let's say E, that would represent a point that is not on the plane. It is either above it or below it. All right, let's talk about our next vocab word right here. We're going to move on to line segments. Now, line segments are very similar to lines, of course, but a segment just means a little piece of it. So a line segment is taking a line, but only a piece of it. So this line does not continue forever. It has endpoints. This is how we represent a line segment, and its endpoints could be called with capital letters because they're points. I'm going to just call them A and B in this case. The naming for the line segment is very similar to what we did for lines. We're going to take those 2 points, the end points, and instead of drawing a line above it, we're going to draw a line segment without the arrows on the end. That signifies that we stop at A and B. Alternate names for this could be BA, but we have to use the endpoints on this. If I had a point in the middle, I cannot use that point to name a line segment. Next, we're going to talk about rays. A ray, again, is very similar to lines and line segments, but a ray continues forever in one direction, but it has an endpoint on the other side. So let's call that endpoint A. Let's get another point over here called B. Let's get a third point in the middle called C, just for good measure. So here we have our representation where it's just an arrow going in one direction. Naming a ray is very picky. This is the pickiest of the names. When we are naming a ray, we must start with the endpoint of that ray. So I have to start with A. I then choose another point on the ray, which tells us the direction that it goes. So this name would be AB, signifies that we start at A, and our line goes towards B, through B, and continues in that direction. If I called it AC, that would work as well, because I start at the endpoint A, I go through the line, or the point C, and I continue in that direction, which is the same direction as when we had B, because these are all collinear. If I called it, however, BA, that would indicate that we start at B this point right here, we go through A and we continue in that direction, that will send us in the wrong direction. So you have to be very careful about how you name rays. And our last vocab word for the day is opposite rays. So that means we're taking two rays, and the word opposite means that they go in opposite directions. So we're going to take a ray, we're going to go here, let's say AB. The opposite ray would go in the opposite direction, so that would go this way. It's important that you start at the same endpoint, and they're going exactly in the opposite direction. I know that one was slanted a little in the wrong way. So they share an endpoint right here, but they go in two separate directions. The first ray would be AB, and the second opposite ray would be AC, where they start at the same endpoint and go opposite directions. Those are opposite rays. Now you'll see a lot of diagrams, different pictures and things. I want to show you a couple of examples right here. This is a picture where two planes intersect. So you can see their intersection point right here is at this line. In my mind, I kind of picture this plane as up and down like this, and that one is sort of side to side. So they're intersecting in this way, kind of like two papers that you've slid together. These dashed lines right there indicate that you cannot see the shape. It's gone behind the other shape. So that is sort of trying to represent a three-dimensional shape drawn on a two-dimensional surface. It's kind of a tough thing for some representations. But keep in mind those dashed lines mean that one shape is behind the other. This example right here is a plane and a line and a bunch of points. So this line, as you can see, is visible here. At C, the line becomes dashed, so that indicates at this point it has actually passed through the plane and it is now behind or underneath the plane. A, B, and P are, sorry, P is not a point. A, B, and C are all parts of this plane because they are drawn inside the shape. So even though this goes forever in every direction, if you want to show that a point is on the plane, you draw it inside that spot. And so A, B, and C are all coplanar. D has been drawn outside of this, so it indicates it's above or below the plane because you've drawn it outside. So this is not coplanar with those other three. E is also not coplanar because it's been drawn away from our representation of the plane. E, we can see, though, is a part of this line, so E and C are collinear, even though they are not coplanar. There's a line that's going through those two. This plane has a special name. It's up in this corner. We called it P, and that pretty much wraps up all of the notation here. So I could ask you a bunch of questions like name 3 points that are coplanar, in which case we'd say A, B, and C. I could ask you to name a point that is not coplanar with those, in which case you'd say D or E, and I could change the variety of these questions in a bunch of different ways. Thank you.